In this paper, we present a novel, hybrid method for modeling ice crystal formation. Our model is based on the physics of freezing, where the process of solidification is commonly broken down into 3 stages. The first stage in the process is known as chemical diffusion. Given a free water molecule and an ice crystal somewhere in space, the molecule must be transported to the crystal. The second stage is called surface kinetics. Once the water molecule has reached the crystal, it wanders along the surface until it finds a place where it can form 2 hydrogen bonds. The third and last stage is the heat conduction stage. When the molecule forms its hydrogen bonds with the crystal, a small amount of heat is produced. This heat then diffuses through space. If all 3 stages occur at perfectly balanced rates, we achieve what is known as ideal growth. This is almost never the case, and the growth process is limited by the slowest of the 3 stages. The case where chemical diffusion is slowest is known as diffusion-limited growth. This case can be modeled by an algorithm known as diffusion-limited aggregation. We show the results of running this algorithm on a house window. If the surface kinetic stage is slowest, we get kinetics-limited growth. This case can be simulated using a class of algorithms known as phase field methods. We show the results of running this algorithm on the same scene. We refer to the case where heat conduction is slowest as the heat-limited case. While complex methods exist to model this case, we produce acceptable results using a commonly available off-the-shelf fluid simulator. Both of the previous examples have visual problems. The results of the diffusion-limited aggregation algorithm looks more like fungus or lichen, and the results of the phase fields look very thick and unrealistic. We observe that all 3 of the limited growth cases can exist simultaneously on different scales. By combining the previous algorithms and introducing fluid flow, we can produce much more realistic growth patterns. We now grow ice on a chilled pint glass. In some restaurants, the glasses are kept chilled in a freezer, and when removed for use, water quickly condenses and freezes on the surface, creating a frost. Finally, we show ice growing on a car in a winter landscape.